Hello my friends, this is 10th issue of the weekly links. To be honest, I have been collecting and publishing links for longer, but only a couple of months ago I decided to add this video format. If you like it and want me to continue, please give me a like, put a comment and subscribe to my channel. What's in scope for today? As ordinary Java. A little about garbage collection, a very good article about Google Guava Cache and a few more useful tools to read about. My name is Alexander Barmin and this is my channel. Let's get started. Let's start with memory management. I suppose this is one of the most popular topics in Java and the main source of thoughts about slow Java. I have heard a lot of rumors around saying that Java is slow because it has garbage collection that stops the world and our customers have to wait till application is back in operation. Well, you know, JVM engineers do their best to solve this trade-off, make pauses as small as possible, make performance as high as possible and memory consumption as efficient as possible. As ordinary, you have to choose only 2 or 3. ZGC intends to provide stop-the-world pauses as short as possible, and the main point is that duration of pauses should not increase the heap size. So, these 2 characteristics make ZGC a good fit for server applications with big heap that require fast application response times. As it is necessary to make some work in parallel, GC will consume CPU, so the research project between Oracle, Uppsala University and KTH did the research and concluded that instead of trying to define size of the heap that will give acceptance performance, it is also possible to define size based on the max CPU utilization by GC. In common, it means that size of the heap might be defined by amount of resource that GC can use to maintain it. Giving more CPU to the GC may allow to get bigger heap size without increasing stop-the-world pauses. As for me, it is a good idea, but let's see how it works in real life. They said that computer science has only 2 complicated problems: naming of variables, cache invalidation, and +1 mistake. Dealing with cache is always complicated, but Guava Cache tries to make it much easier. In the most scenarios, it is better to store cache data outside the JVM, for example in the external service like memcached or Redis, but in some cases it would be nice to store the data locally. Obviously, we can rely on abstractions like Spring Cache, but also we can make the work with cache more transparent by using Guava Cache. I like Guava Cache, to be honest, because it is very flexible but also simple. There is no need to put data into the cache directly, it has cache loaders instead. Cache eviction is the main problem and Guava Cache solves it gracefully. We can limit size of the cache and limit time the data stored in cache or not in use. Another good capability is also connected with garbage collection. We can ask Guava Cache to use weak keys and soft values. Actually, there is no need to store data that it is not in use, so if weak keys are enabled, GC will be allowed to remove data that is not referenced. In code, it is possible to subscribe to the data cache eviction. Keeping cache data up to date is complicated as well, and here Guava Cache helps us to do it. It is possible to refresh cache data manually or use automated cache refresh. Personally, I use Guava Cache in multiple projects and would say that it is the most convenient cache library I have seen. Of course, it may not help when you need to store cache data outside of the JVM, but in case if it is okay for your use case, it is a super convenient tool and I strongly recommend you to use it. Moving forward. Relational databases, I assume, is the most popular type of databases, at least at the moment. We have normalization and it is necessary to use it to avoid data duplication and inconsistency. It is achieved by creating separate tables for different data and establishing a relationship between tables. There are 3 common types of relationships: one-to-many, many-to-many, and one-to-one. I suppose there are no questions regarding one-to-many and many-to-many relationships, but what can be a use case for one-to-one relationship? The main use case here is to split the data. Let's imagine a situation when we have a very wide table with many columns. In case if this table is regularly updated, even in the best scenario the whole record will be blocked. But in case if different users or processes need to update some columns separately, it makes sense to split one big table into a few smaller tables that will have separate logs. Another reason is unsurprisingly performance. Yes, when it is necessary to read a huge record from the database, more likely it will be read from disk but not from cache and RAM. In case if the record is small, it will be read from cache with higher probability. Obviously, there are a few more possible use cases for this kind of relationship. For example, you already have a huge table with many records, and adding a new column will cause a massive impact, because it's necessary to block a table for some time, to rebuild index, to allocate new disk space, and so on, to do some maintenance. In this scenario, it might be easier to create a new table with additional columns and establish one-to-one relationship between existing and new tables. Okay, I hope I shared a few use cases for one-to-one relationship, and it is not a strange idea anymore. Dealing with data is challenging, especially when amount of data is huge, the data is distributed geographically, or the data is ingested regularly in high volume. In common, if your data is big data. The first approach is partitioning, when single piece of data is split into smaller pieces. For example, you have a big user database, and users with login that starts with A to L is stored in one partition, users from M to Z are stored in another partition. In this case, the system is more fault tolerant, because in case if one partition is down, other partitions still can serve requests. Another great benefit of partitioning is an ability to vertical scale node. Obviously only up to some extent, but in case if a particular node cannot be scaled anymore and accommodate more load, the data might be split again, and in this scenario either low-end hardware or VMs can be used to serve significant workload. There are different approaches for partitioning, but there are two main approaches, obviously horizontal and vertical. In case of horizontal partitioning, the record is fully stored in one partition. In case of vertical partitioning, different parts of the record can be stored in different partitions. So this is one challenge. Another challenge is how to split the data properly, perform queries that affect many partitions, and other like updates of the data that is stored in multiple partitions. And here we have different options like two-phase locking and two-phase commits. Another using approach to know is data replication. In this case, the same data is stored in multiple places, so that the storage is more fault tolerant and can survive even after losing one of the replicas. The main challenge with replication is that it is necessary to keep replicas in sync. The data should be the same across all the replicas. There are many different strategies for solving it, but there are two well-known: primary backup replication and consensus-based replication. In case of primary backup replication, there is one node which is responsible for writes and other nodes which are literally backups. In this scenario, the primary node is responsible for making sure that replicas store the data successfully, and only after that it notifies the client that the data is actually written. In case of consensus-based replication, all the nodes can perform read and write operations, but in order to do that, and in order to return consistent data, every node should communicate with other nodes and make sure that node performs write and ready to return consistent data during reads. And obviously there are systems that use both partition and replication. Well, because I'm talking about articles, more details you can get from article. So please read articles which I'm sharing, because I'm not sharing all the details about articles, I'm just sharing some thoughts and my feedback regarding them. So it's also good to read articles I'm recommending you to read. The last one article in my list is a short comparison of Spring Cloud Gateway and Apache API 6 or API 6. Both of the products are API gateways. Spring Cloud Gateway is a Spring Boot starter that requires a Spring Boot application, and API definition here can be configured in code or using YAML. Apache API 6 can be configured using admin API or using a YAML configuration. YAML configuration, by the way, is a quite convenient option for GitOps. By making change in the YAML, you can trigger a deployment of this YAML. The article includes detailed comparison of features, and in common, both the products are doing the same, have similar features, but use significantly different approach. So, in case if you're looking for API gateway, you may consider this as an additional option. So, before making a decision, please give it a try as ordinary. That's it for today. Hope you enjoyed the video, and if so, please give me a like and write a comment. I also encourage you to put links to other articles you want me to read and share my thoughts. Also, if you have other suggestions regarding the formats, do not hesitate to let me know about it in comments as well. So, let's call it a day. See you next week. Bye.
Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my ass.